See, now this is working as what? Multiplexer. Let us copy this output here and analyze. 0 means what it has to select. I0. 0 1 means what? I1. 0 1 is I1. 1 is I3. 0 1 is I1. Now this is also fine. What is this program is? Control statement with what? Only the if statement. The one which we did earlier using nested if statement. Correct? Now can I ask you a few more programs? Can you write a program for that? Behavioral model program using conditional statements. Okay. Now you take a program. Just let me copy this here. Now you can write a program of. Let us write a program of 2-bit comparator. 2-bit comparator using conditional statements. Using conditional statements. Write a program of 2-bit comparator. What is 2-bit comparator? What is 1-bit comparator? Comparing 1 bit with 1 bit. 2-bit comparator means 2-bit comparing the 2 bits with the 2 bit. Then magnitude comparator means what? Suppose 4-bit comparator is nothing but we can call a magnitude comparator. 4-bit data, parallel data. We're comparing with other 4-bit parallel data. I think one example we have done in the data flow modeling, I think so. Comparator, magnitude comparator design using data flow. Correct? So we are writing the big expressions for A equal to B, A less than B, then A greater than B. Then using assign statement, we are writing very big Boolean expression. Correct? Using data flow modeling technique, if you remember. Now this is a question of 2-bit comparator. So to write the behavioral model, you don't need of what? Logical expressions, correct? You are writing the behavior of that circuit, how it will behave, correct? Then how to write a program to this? What is 2-bit comparator? What are the outputs of the comparator is? A is equal to B, A greater than B, A less than 3 outputs, correct? Can you write a program to this? Using the conditional statements, if statements, if else statement or nested if statements. What I need to do? First start with what? Module. What is module name is? Shall I write comparator to? Means it is a 2-bit comparator. Short notation of comp is comparator.
ये अपना वो कम
So
नहीं
what are the
मिलता हमें
inputs to this is?
ये
A
अपना
and B
सही
I can
साबित
write.
करना
A and B are the inputs. Then what are the outputs are? Shall I write A greater than B like this? A greater than B, A equal to B, correct? Then A less than B, A less than B, correct? A less than B. Then what I need to do? How to declare this? What are the input ports are? A comma B. So whether it is a scalar or vector, 2-bit comparator I'm talking. Vector means what? 1 down to 0 of what? A comma B. Then what are the output are? Output range type, correct? A greater than B, A equal to B, then A less than B, correct? Then initial block or always block? Always block, correct? Always at the rate event I need to write. Event of what? Star. Shall I use star? Again, begin. So if there are multiple statements for my always block, I should begin with the grouping with the begin and end. So let me write begin and end. And how to write the program for 2-bit comparator. 2-bit comparator. How to write the condition to this? How to write the condition to this? If I can write A is greater than B, correct? Begin What is statement I can write? A greater than B should be is equal to what? 1 or 1 tick B1. Correct. Then what should be A equal to B? 0. Correct. Then what is A less than B is equal to 0. Correct. 3 statements I am writing. If this condition satisfies, if A is greater than B, I should write what? I should make A is equal to 1. These are A greater than B is 1. A equal to B is 0. A less than B is equal to 0. That is the condition, right? For comparator. If A is greater than B. So then I should, what I need to do? End. Correct? Next, what I can do? You can do this using only the if statement also. I can do this using nested if also. Correct? I can go with the nested if. Else, if, what I need to do? What is the condition to this is nothing but A equal to B, correct? Begin. A equal to B, begin. Next, what I need to do? What is the statement I should write for this else if body? A greater than B is equal to now what? 0. Correct? Now, A equal to B is equal to 1. 1. Next, A less than B is equal to 1.
कौन सा नशा करता है कि भूल ही जाता
Then I should end this.
नशा ही करता है तो इंसान भूल जाता है
Next, what I need to do?
इंसान ही भूल जाता
I can write the else. Correct? Else if I can go or else I can write. Else is fine. Correct? If it is
मुझे
greater
लगा
than,
ब्रेन हेमरेज का इफेक्ट
equal,
ज्यादा देर तक रहेगा
next is what?
मरते तक तो
Less
नहीं
than.
जाएगा
Then I can go with the begin. What I need to write here? A greater than B is equal to what? 0. A equal to B is nothing but what? Is 0. Then A less than B is equal to what? 1. Then I need to end this. Correct? Now what I need to do? End the initial begin. End the initial begin. Then end the module. End module. So these statements I can also write like this, right? The single line. Because I'm using semicolon.
तू अभी भेज
This I can write
तू आती जब
like
जाता
this also.
अरे मजदूर लोग गाठिया खाता
Let me write here.
एक दिन तो आज अगर मजदूर है
How many statements?
कल ही समझा दिए
How many statements I have in the else, if, else if body? 3 statements. One is A equal to B, A less than B, A greater than B. Now this is my design file. Now let us run this for what? Syntax. So there is a line number 12. What is the line number 12? Is it else is? I am checking for what? A greater than B, A equal to B. Whether I go with A equal to B or A equal to B. This should be the condition if A is 30, B is also 30. This condition 30 is equal to 30. Correct? 30 is equal to 30. So what is this conditional expression? Small form conditional expression. A greater than B I am writing. A equal to B I am writing. Yes, here it need a gap. There is a space between else and if. Okay. Now let us debug this program. This is A greater than B equal to B less than B. I mean this if. Then I am starting else if. The condition for the else if I am writing is A is equal to B. Then begin. A greater than B, A equal to B, A less than B. Then I mean this. If this is not, both are not true, then I should go with this condition. Else begin. Greater than B 0, equal to B 0, less than B is equal to 1. Then I'm ending this. Then I'm ending the always. No? Now I am checking this is greater than, correct. How this condition of the else will evaluate? If it is true, it will go this condition, right? The operator I should use this is for what? Is equal to B operator. Equality operator. Then this is else for less than. Did you understand this? Now let us write the what? Test bench to this. How to write the test bench? Module, TB, reg. What are the regs? 1 down to 0 of A comma B. Then while A greater than B, correct. A equal to B, A less than. Then we need to instantiate the design. Comparator to DUT of, let us go port connection by default. Now I am going to begin with what? Begin to initialize the values of A and B, generating the inputs, and then apply this and collecting the output. So to generate the input, I will be going with the concatenation. A comma B is equal to what? Shall I go with $symbol random system task function to generate the random values? Let me give some delay, sim delay. Now what I need to do? Display of, or you can monitor also, right? $symbol monitor out, $symbol monitor will work. It is continuously monitoring. Whenever the values of variable or a signal changes, only it will monitors. If it does not changes, it is not going to monitor. So let me write $symbol time. Okay. Then double quotes. Let me give the tab space, escape character. A, shall I print in this in the decimal? Correct. Then, comma, B is equal to what? D, decimal. Next, what I need to do? A greater than B is equal to what? Percentage B, comma, A equal to B is equal to what? Percentage B, comma, A less than B is equal to what? Percentage B. So can you pass the arguments? A comma, B comma, A greater than B, comma, A equal to B, comma, A less than B. So I need to change it. This is not dot, comma. Is also comma. Correct. Next, what I need to do? End this line, then end the initial begin, end the module. Correct. Now let us run this program. So since I am declaring A, B are what here? Reg data type. Correct. Reg data type. So I am doing for what? 2-bit comparator. So let me print the A and B are also what? A and B are in binary. Let us print in binary itself because I need to compare what? 2 bits with 2 bits. So 0, 1, A is 0, 1, B is 0, 0 means what? It is a greater than. A greater than should be what? 1. A equal to B is nothing but 0. A less than B is equal to 0. Correct. Now can I repeat this part 10 times? Repeat 10 times. Begin to check all the possible inputs. Then I'm going to do end module. Okay. Now let us run this program. Now this is output. Now let us analyze this output. So A is what? 0, 1. B is 0, 0. Means A greater than B. 0, 1 is, what is decimal notation of this is nothing but 1. 0, 0 means 0. Now A is greater than B is 1. Correct? Next, 0, 0, 0, 1 means what? A less than B is 1. Correct? Now this is nothing but what? Greater than. This what? Less than. This is what? Greater than, equal. This is less than, less than, greater than. Now we have modeled the 2-bit comparator using what? Using conditional statements. Correct? Are you understanding this program? Hmm? Now can you do next program? Hmm? Okay, write a program. Write a program. Write a program of D flip-flop. Write a program of D flip-flop. D flip-flop using conditional statements. Using conditional statements. Using conditional statements. What is D flip-flop? How you can write a D flip-flop? Characteristic table of the D flip-flop is clock. Correct. If I am talking about clock is the input, D is the input, Q is the output, and Q bar is the another output. Correct. So you can write when the rising edge comes. Positive edge triggering flip-flop, D flip-flop I am talking about. Correct. You can write D flip-flop, you can design the D flip-flop right like this, reset. If reset is equal to 0, or you can write reset is equal to 1, reset is equal to 1, irrespective of your clock and D value, whatever the value of clock and D, you make a Q is equal to 0, Q bar is equal to 1. Are you understand? If reset is equal to 0, whenever clock rising edge comes, if D is equal to 0, Q is equal to 0, Q bar is equal to 1. If reset is equal to 0, whenever rising edge comes, means what triggering flip-flop it is? Positive edge triggering D flip-flop it is. D input is 1, what is output is? 1 and 0. For this, can you write the behavioral model? This characteristic table, this behavior, can you represent in the conditional statements? So what it says that this is my clock. This is my clock. This is a rising edge of clock, rising edge of the clock, rising edge of the clock, and rising edge of the clock. So this is a rising edge. This is a rising edge. This is a rising edge. Rising edge. This is my clock. Correct. Let me draw the reset. When reset is I, what you need to do? Reset is I. Let me write reset is I. What is Q I want to do? Irrespective of my clock and D. Correct. So let me write D here first. D, I'm going to write this is nothing but X. Means don't care, irrespective of this. Irrespective of the clock also. What is Q I should do? 0. Q is equal to 0. Then what is Q bar is nothing but? Q bar is nothing but complement of the Q. 1. Correct. Now whenever rising edge comes, if my reset is low, whenever my reset goes low, this is reset is I, irrespective of the D, Q is 0, Q bar is what? 1. Did you understand? When my reset is equal to low, 0, what I want to do? What I want to do? Reset is low, whenever rising edge comes, if my D is 0, what is output is? 0. If D is 0, output is 0. What is D? Q bar is complement of this. Did you understand? Whenever rising edge comes, reset is low. If D is equal to 1, D is equal to 1, correct? What I want to do? What is D flip-flop means? Q follows the D. Now Q should be what? 1. and Q bar should be what? 0. Complement of this. So this behavior you need to model using the behavioral model using conditional statements. Using conditional statements. Can you write a program to this? Write a program to this. Write a program. D flip-flop means output follows the input. I'm using one more input, reset. This reset is used to control the Q. If reset is like irrespective of my clock and D input, whatever I'm giving, always Q should be 1, 0. This should, flip-flop should work as a output follows the input only when reset is equal to what? 0. So again reset are 2 times. Synchronous reset and asynchronous reset. Synchronous reset means that reset should be synchronized with the clock. Asynchronous means irrespective of the rising edge or falling edge what you are designing, once reset becomes high, Q suddenly becomes what is the condition you are writing, Q follows that. That is not sync with the what? Clocks. Clock edges. Correct? Can you write a program to this? What is a program to this? So what are the inputs to this is module? So selecting D flip-flop of what? Clock is a 1 input, reset is 1 input, D is a 1 input, Q bar, I am writing Q bar like this. Then what I need to do? Input and output declaration. What are the inputs are? Clock, reset, D. Correct. Then what are the outputs are? Output, reg, Q comma, Q bar. Correct. Next what I want to do. So procedural blocks always at the rate. Now I should write the event. Correct. What event I should write? Whenever rising edge comes. Correct. Rising edge comes. D, Q follows the D. Correct. Q follows the D. So but I need to write a condition that if reset is equal to 1, Q follows the 1, 0. Correct. Q follows the 0. So always at the rate of what edge? What is the keyword to this? Is nothing but passage. Passage of what? Clock. Passage of the clock. This is the event I am writing. Begin. And what event it is? Regular based event this is. What are the event? How many types are there? 3 types. What is first type is? Regular event type. Named event, control or event or control. Now what event I am writing here? Regular event. Correct. Always at the passage, always at the clock, always at the negates. Correct. Always at the passage or negates clear. You understand? So this is a regular event. Then always at the passage of the clock, what I want to do. Now I need to use the conditional statements, right? If correct. If what I can write? I can write a reset. This reset value I'll be initializing in where? In the design file, test bench file. Correct. If the reset is equal to 1, what I need to do? If value of this reset is equal to 1, Q is equal to what I need to do in this case? Begin. What I need to write? Q is equal to 1. So shall I go with, this is a sequential part, what blocking I can go with? What procedural assignment? Non-blocking procedural assignment. Did you understand? Even you can use blocking also here. We saw some differences between blocking and non-blocking. Since I am talking about sequential, correct? So I can use what? Non-blocking statement. Q is less than or equal to what I need to assign. Let us write one tick B0, or if you write 0 also fine. Is it clear? Then what is Q bar is? Q bar is what? One tick B1, or I can write what? Not of Q. Not of Q. If Q is equal to 0, what is Q bar becomes? 1. So this is the what else? When? If reset is equal to what? If reset is equal to 1, I am doing this. This is what I am writing the truth table here. You can see. If reset is equal to 1, irrespective of the what? Clock and D, Q is equal to 0 and Q bar is equal to 1. Correct? So this will do, these blocks will execute whenever what? Rising edge comes. Positive edge comes. How do you understand this? Then what I need to write? Else. Else, what I need to do? Begin. What is else body I should write? What is the else body? If reset is equal to 1, it goes here. If reset is equal to 0, where it is going? Else body, right? What is else body I need to write? Q, non-blocking statement, less than or equal to what? D. Correct? Q follows the D. What is Q bar is? Q bar is less than or equal to what? Not of Q. I can write not of Q. Not of Q. Correct? Then what I need to do? So here I think I will not end this, right? Multiple blocks are there. I need to end the if. Then here this is the my else body. Else body also multiple statements are there. I should group it what? End. Correct? Then what I need to do? We are done with this program, correct? Then what I need to do? End the always. Then end the module. End the module. Did you understand? Now let us run this for what? Syntax errors. Is my program is correct? Using what statements? Conditional statements. Now how to write a test bench to this? Can you write a test bench to this? Module. Module name is what? TB. Then what are the edge type are? Clock. Then reset. Then T. Then white types are Q and Q bar. Now I need to instantiate the what? Design. This is nothing but what? D flip flop. This is what? DUT. So I'll be going with the port connection by name or a sequential circuit. Let me go with, if you go with a dot star also no issues. Okay. Better I used to follow for what? Port by name. Dot clock of what? Clock. Dot reset of what? Reset. Then this is dot D of what? D. This is dot Q of what? Q. Dot Q bar of what? Q bar. Is an instantiation of what? Design. Next, what I need to do? We need a clock, right? We need to do the clock generation. How to do the clock generation? What procedural blocks I can use? Always, correct? So let us give that time. As 5 means what it will take. T on should be 5, T off should be 5. Total time period is nothing but 10. Then what I need to do? Clock is equal to not of clock. This will be generating the always clock, will be generating the clock. Now what I need to do next? Initialization. initial begin, correct? Initial begin, what I need to do? First I'm going to initialize clock to what? 0. Clock to 0, correct? So this will be executing at what time? At time t is equal to 0. So now I'm going to make what? Reset is equal to 1. Reset is equal to 1. So can I initialize d also some value here at time t is equal to 0? If I'm not going to initialize, d becomes what? Unknown. Correct? Now I'm going to give hash file. Hash file. Then what I'm going to do? The clock is anyway, clock will be generated using always clock. Correct? Now I should make what? Reset is equal to 0. Reset is equal to 0. Shall I make d is equal to what? 0. So let me give at time 15, or let me give at time 25. 25. What I want to do? Reset is 0 already. Now I'm going to make d is equal to 1. Correct. Then let me give some time at 55, somewhere 55. I am going to make what? Reset is equal to again 1. Reset is equal to again 1. Then I am going to end this module. End this module. Are you clear? Did you understand this initialization? Now I am going to go with initial begin. Initial begin. Let me monitor this values. Dollar symbol monitor. What I need to monitor? Time. Correct? Dollar symbol time. Then what I need to print here? Clock. Clock is nothing but what? Percentage B. Comma, next what I need to do? Reset is equal to percentage B, comma. D is equal to percentage B, comma. Q is equal to percentage B, comma. Q bar is equal to percentage. Now what are the argument I need to pass this? Clock, reset, D, Q, Q bar. Then end this line. This is D. This is D. Q bar. Then end this. Correct? Now let me give the time to finish this. Let us give time is 100. Okay. Then I am going to do dollar symbol H. Then I am going to end this initial. Then I need to end my test bench in the module. Do you understand? Now first let us run this for the syntax error. Then we'll go for the output analysis. So this is the output. Okay. Now let us, so my syntax is clear, correct? This is the output. Let us analyze this output now. So at time t is equal to 0, what I am doing at time t is equal to 0? Clock is equal to 0. Reset is equal to 1. And d is nothing but 1. Correct? D is unknown. But when reset is equal to 1, what it has to do? Irrespective of d, when reset is equal to 1, Q is equal to 0, correct? Q bar is equal to 1. But what happens in this case is, it is taking unknown, at time t is equal to 0. Now time t is equal to 5, what I am doing? I am making reset is equal to 0. Reset is equal to 0. So let us analyze this output first, whether it is working according to what we are writing, initializing the value. Okay. Let me do one thing. Let us remove this. Let us give the timestamp of, let us take 25. 25. Up to 25, I'm going to make the reset is equal to 1. Okay, rising edge will start at 5 only. Until that, my reset is equal to 1. So instead of that, what I'm doing? At time 25, I'm making what? Reset is equal to what? 1. When reset is equal to 1, what we are doing? Program. We are assigning Q to 0, Q bar to 1. Q to 0 and Q bar to 1. Now let us analyze this program. Now after this, there is a reset 20. Let us make this to, let us take this to 50, up to 50. Now let us make this is up to 90. At 90, I am making reset is equal to 1. Then at 100, I am finishing this. Okay. Now let us run this code. Now we'll start analyzing this one. Now this is working fine. You can see here, at time t is equal to 0, clock is 0. And then reset is equal to 1. Now d is unknown, q is also unknown, q bar is also unknown. Because I am writing what? Positive edge. Always my reset will change at what edge? Positive edge. Because at the rate of positive edge, inside I am writing the what? If reset. If reset clock is equal to 1 is a positive edge here. Reset is equal to 1. When reset is equal to 1, irrespective of the d, what is q is nothing but 0. What is q is equal to 0? Then q bar should be what? Q bar should be 1. But this changes is happening at the next rising edge. Q bar is falling at the next rising edge. We'll run this in the model sim and we'll see the timing diagram and we analyze. Before that, up to 20, 0 to 25, I'm making what? Reset is equal to 1. Now Q becomes what? 0. So when reset is equal to 0, what we are doing? When reset is equal to 0, Q follows the D. Q follows the D. Now it is following the Q follows the D and Q bar is equal to 1. Are you clear? Did you able to understand this? Okay. Now when I am making reset D is equal to 1 at the clock 75. The clock 75, until that Q is following the D only, right? Since reset is low, reset is low and whenever the rising edge comes. When D is equal to 1, when I am making D is equal to what clock? 75. Here clock is rising edge. Clock 1 means 0 to 1 transition means rising edge. Rising edge. When reset is equal to 0, what is Q is? Q following the D. And Q bar, we need to check the logic here. Okay, Q bar becomes 1 here. So we'll run this in the model sim and we analyze the timing diagram according to the sim time which I am giving to the program. Now this is working as a D flip-flop according to the model which I am writing. Okay. Now let us run this program using model sim and analyze the timing diagram. Okay. For this, what I need to do first. So let us create the folder D flip-flop. First, we need to design the design file. Let us copy the same program here. This is save as what file. Let us make this is D flip-flop.v extension. The file format is R. Now I have made this into D flip-flop file. What is next? What I need to do? Test bench. Let us copy the test bench. This is a test bench. What is the first line I should include? Tick include. This is nothing but what? D flip-flop.v. The extension I am giving is a D flip-flop.v. File save as. File save as. Let me save this into tb.v. Then all files. After this, what I need to do? I need to make the run.do file. So what is the commands to the run.do file is? Can you tell me what is the command to the run.do file is? These are comments, correct? VLOOK, before that what we need to do? VLib, right? VLib work library. Then tb.v. Then this is what? I think this is not necessary, right? This is a Costa sim command. This is what? vsim tb. Then add the will sim tb and dut and start. Then -r file. Save as. What file? What extension I need to do? Run.do file. Just save all. So now I have created all these three files. So this is a multiplexer, sorry. This is a D flip flop. Now let us remove this notepad. This is a design file, this is a test bench, this is a run.do file. Now I am going to invoke the tool. So open the terminal, model sim -. I'm running the command here itself. -do run.do all. Now let us open this file. Now this is the monitoring output I am using. This will monitor same. Same thing which is displayed in the online compiler, right? Now let us analyze the waveform. So this is my clock, correct? This is a clock. This is a time t is equal to what? 0. This is a rising edge. This is another rising edge. This is another rising edge. What is the timestamp to this? Time t is equal to 0. So what is my reset is I'm doing is? Reset is made I until what timestamp is? 25. When reset is I, what we are doing is? You see the program, what we are doing when reset is I? Q is equal to 0, Q bar is equal to 1. Correct. Now this D is nothing but here unknown. D is unknown. We are not declaring any D value, right? When reset is I. So D is unknown. But output Q changes at what? Whenever it comes what? Rising edge. This is nothing but what reset it is? What reset? Asynchronous reset or synchronous reset it is? This is nothing but a synchronous reset. Because, see, when reset is I, Q should be 0. Correct? But we are writing the synchronous reset. This reset will be synchronous with the what? Clock. Whenever reset is I, when rising edge comes, then only Q becomes what? 0. Did you understand? Are you able to understand this program? Then what is Q bar will be? Q bar will be complement of this. This effect is changing at this rising edge. Q bar becomes complement of this nothing but 0. This is I. This effect is happening at this rising edge of the clock. Now coming again at this rising edge of the clock, what is my reset is? 0. Irrespective of the D, my reset is 1. Here reset is 1, irrespective of the D, Q what? 0, 1. Did you understand? Now at this rising edge of the clock, what is the reset is? 0. Reset is 0. When reset is 0, what is the program we are writing? Q follows the D. What is the D value is? 0. Now what is Q is? 0. What is Q bar is? 1. Correct? Now again what I am doing here is, at this, what is the timestamp is nothing but 75. The 75, what is my reset is? 0. What is my D is? D is 1. Now Q following the what? Q follows the D. Q is equal to 1. And then Q bar is changing at this rising edge of the Q bar. Now let us go to the test bench and we'll analyze this timing diagram with the test bench. We are writing the simulation time. Okay. This is my test bench.
Hello, sir.
Yeah, hello.
Sir, in first
Yes, hello.
positive, yes, sir. In positive edge, sir, Q bar and Q both are 0, sir.
Okay, let us clarify this now. We are writing, let us go to the design file. Design file. This is my design file. So what we are doing in the design file? Whenever pass edge comes, what you are doing? If reset is equal to 1, Q becomes 0, Q bar becomes complement of this. Correct? Q bar is complement of this. Else, reset is equal to 0, what we are doing? Q is equal to D, Q bar is equal to what? Complement of this. Complement of the Q. This is my design file. Now coming to this test bench. Test bench, this is executing at what time? At time t is equal to 0. At time t is equal to 0, what is my clock is? I am initializing to 0. Clock will get changes at what time? I am generating the clock of what period it is? Time period of 5. T off should be 5 and T on should be 5. Total time period is 10. Now time t is equal to 0. What I am doing? Clock is equal to 0. Reset is also 0. Now let us come to this point. So this is at time t is equal to 0. What is my clock is? Clock is 0. Up to timestamp 5. At the 5 timestamp, what will happen? Clock is complement of the clock. This is what clock generating. Initially, if this clock is 0, at the 5 timestamp, what happens? Complementing the clock. Means clock becomes 1. Again, after next time, 5 timestamp, what happens? Clock is 0. Again, next 5 timestamp, clock becomes 1. You need to understand this. Now coming to this, at time t is equal to 0, clock is 0. What is reset is? Reset is I am making 1. At time t is equal to 0. Then when I am making reset is equal to 0? At the time what? 25. So this up to time 25, from time t is equal to 0 to time t is equal to 25, what is my reset is? Reset is 1. What is the d value in this case is? Don't care, unknown. Correct. Now you can see the output here. What is the output we are writing? Whenever positive edge comes, correct. If reset is equal to 1, what we are doing? Q is equal to 0.